There's a thrilling development in the data engineering arena this week. Databricks has open sourced their Unity Catalog system. This versatile catalog for data and AI is now an open source project with its code readily available on GitHub. Having been published a mere couple of days ago, it's fresh and ambitious. Feel free to take a sneak peek at the actual features on their website. And it's worth highlighting that this innovation is under the Linux Foundation's stewardship as a sandbox project. Today, we'll dive in and lay the groundwork for this service on a cloud-based VM. Showcasing Google Cloud's environment today, rest assured the basic hands-on setup will synchronize well with other VM hosting environments or even your own personal laptop. As we ignite the Compute Engine API, let's pause for a moment to explore the Unity Catalog's expansive potential. This versatile tool integrates seamlessly with various cloud providers like AWS or Google Cloud. A game changer, it greatly facilitates cataloging and can sit atop a broad set of data assets. Its flexible construct allows both internal and external data source integration. And regarding data processing, it's a friend to frameworks like Spark, among others. Given that Databricks, the mastermind behind the Unity catalog, has Spark as its beating heart, this comes as no surprise. But wait, there's more. We also have ELT technologies like dbt to boast about. While we won't step through each integration today, feel free to peruse the documentation and diagrams for that. I do want to highlight the special AI-focused integrations. Intriguingly, LangChain is one such example. Let's shift gears and return to our Google Cloud project to create a VM for our Unity catalog. Although we have the flexibility to customize this VM, we'll opt for the default configuration, a popular choice that costs approximately 3 cents per hour. Perfectly suitable for our demo today, feel free to scale according to your requirements. After authorizing with our Google Cloud credentials, we're ready to courageously SSH into the unit. Excitement mounts as we clone the Git repository. Given that our Debian box is missing the Git command, let's swiftly install that next. Second try and voila, we've got our Unity catalog repo in hand. We now find our commands stored in this bin directory, ideal for kickstarting the Unity catalog server. It appears a Java environment is necessary here, so let's proceed to install that. Keep in mind it requires JDK 11 or higher. Thankfully, we have Java 17 in the vicinity. Let's experiment with that. Empowered with a Java environment, it's finally time to give our build a shot and launch the Unity catalog. All right, folks, our Unity catalog is all systems go. But what if we want to throw open the windows and let the world see it? Keep in mind our Unity Catalog APIs hum along nicely on port 8080. We'll expose this rather broadly with a network-level firewall rule, but don't follow our insecure example if you're in an existing or production project. Now let's put on our helmet and head over to the Unity Catalog firewall rule. Scroll down all the way to the bottom, and you'll see this VM that we set up. It's under the influence of this new rule. No stopping us now, let's access that endpoint. Bingo, everything's up and running as expected. Next, to explore other CLI commands, why not entertain ourselves with another SSH session? Taking a trip back to this directory, you'll see that we are kings of our castle, controlling the essential assets of the Unity system. Look around, you'll find gems like our Unity catalog, and we can peek behind the curtain at the schemas in the catalog. But hang in there, let's see how tables have fared using our nifty Unity catalog table list command. You'll see some are cut off, hard to read, but we can enlarge and inspect. We've hit the jackpot with various technical and metadata details, all while showcasing an external data asset in the sleek Delta Lake format. Now, remember that our system plays nice with gold standard data sources like Postgres and BigQuery, but is open-minded enough to work with alternatives like Apache Iceberg. The beauty of the CLI is not just in reading, but also in creating. We're going to whip up some tables, defining columns and pinpointing a storage location. Once our table is ready to go, we can inspect it. It's a newbie with an empty directory other than a Delta Lake log. Check again to list our tables in the schema, and voila, a brand new table on the block. In the spirit of cataloging, you can also manage volumes, much like tables. Just a couple of examples are prepped and stored in a directory for you to experiment with. No limits here, folks, we can create volumes too. Bear in mind there's a whole buffet of functions you can manage using the CLI. And yes, you can support multiple REST catalogs with allies like Iceberg or Apache Spark. Let's circle back to our endpoint. We can use endpoints in this neighborhood by visiting the docs and checking out our Catalog API, Iceberg REST Catalog API, and our familiar Delta sharing. As always, we'll include the diagram file in the video description. Thank you for joining us, and please enjoy it responsibly.